Hi, this is Francisco with Alana and Shin and in Chapter 3 we'll be talking about the general methods for generating random variates. For the overview, we'll talk about random variate generation, and then we'll go to inversion of cumulative distribution function, also known as the CDF, and then we'll talk about the envelope rejection example that we'll show you later on in the slides.
For the random variate generation, it's assumed that the distribution is completely specified and we want to create samples from that distribution and put them into a simulation model. There are different methods or techniques to do this. We will focus on the inverse transformation, which is the sampling of a method for generating random numbers from any probability distribution by using its inverse cumulative distribution. The acceptance rejection method would be used if an inverse transformation method is too hard to solve for the function. This method generates a random point on the graph. If the point lies under the graph, then it is accepted, otherwise the point is rejected. The convolution method is expressed as the sum of the random variables and it results in a random variable itself. For the inverse of the cumulative distribution function, here the continuous random variable is defined as the probability that the random variable, the big X, is less than or equal to the actual value, denoted by the little x. We start out by integrating our distribution function, and we get 1 minus e to the negative lambda x, which is our R value. And from there, we solve for big X, which is the inverse, and this would give us our random variable.
Now we'll be discussing the envelope rejection example. So as stated previously, there's different methods that can be used, and the method that is going to be used here is the acceptance rejection method. And again, the reason for using this is when the function is too complex to figure out, we have to use something else, and that would be the acceptance rejection. And here we have two different functions that we're really looking at. We have the h function, which is the actual function that we're trying to figure out, and then we have the g function, which is going to be over top of the function we're trying to determine. To get a better view of this, here's a graph of what I was trying to talk about. So the blue line or curve, you can see this is the h function, which I talked about. This is the function that we are trying to figure out. We don't have a actual equation for this curve, but for the g function, we do have an equation for. So with the acceptance rejection, we have different random variables, and if one of the variables is inside of or under the h curve, then we are going to accept it. If it's outside of it, then we're going to reject it. And we're trying to figure out the acceptance with probability of the h function over the g function. Thank you for watching our video.